So now I have a question for you. So you have, by this time you have written many programs, right? So how do you debug your program? When you first, when the course started, what is your usual debugging strategy? Okay, you use lot of printf, right? Printing values of variables. We use extensively printf to so that is the anyone who starts new in programming, the way we debug, even not only new, even if you're an experienced programmer also, printing the output and tracing the behavior of the program is how we usually debug. It's the most common way of debugging a program, using printf statements. So number one, printf statements, debugging techniques. And of course, the second approach is use GDB. We use a debugger and so what happens when we use a printf statement, like for example, let's say in order to understand what is, this is the code for insertion sort. Okay, this is the code for insertion sort. So what do we typically do when we are debugging? In order to see that everything is all right, we say when we are in printf, we say insert insert node case base case 1, case -1 or base -1 case. This is the, so we want to know where we are. We want to be, so that way if there is some problem, we know exactly where that problem is. And then similarly, we say, if it is, we are looking at the insertion sort code that we have written before. Now, instead of using the multi-file program, we are just using the single file program so that it will be easy on you. And then we'll say, hey, this is, we are in insert node and we are in base case. Similarly, there are 4 cases we thought of, and yeah. So here, somewhere here, you may want to write inductive case. Inductive case plus, right? And then, yeah, so these are the things that we have. Let's say I just comment out all these things and just have print list here. Now let's compile this code and see what happens. GCC CP21A, GCC insertion sort.c .a.out keys.text. Now you can see that initially when we inserted an element into the empty list, we entered the base case -1, and then we entered base case inductive case +1. I don't know why we got into inductive case +1. That is when we are trying to insert it in the middle, we will be in the inductive case +1. And when we insert it at the end, sorry, when we insert an element at the end, then we get an inductive case plus 1. And if you try to insert it in the middle, we get an inductive case. That is, we are inserting in the middle. Are you with me here? Do you recall? Base minus 1 case, inductive case, base case, inductive case, so on and so forth. Okay. So essentially, we use the print statements to debug our program. But after everything is done, what do? We want to remove these print statements, right? Yes or no? Let's say before you submit your assignment, you want to remove all of these printf statements, right? So what do? Then you have to manually go and comment them, uncomment them, all sorts of problems you have. So one way of solving this, nice way of solving this problem is, we enclose these printf statements into what are called as if def debug and if. Okay, so now see, we are enclosing. So debug is a macro. Let's finish the code and then we will I'll explain what's going on. Hash and if. Okay. So now what we do is when we compile, so we compile this program, GCC, what is this program name? Insertion sort.c. And when we run it with keys.txt, you see the debug, the print statements are not visible because the print statements are enclosed. The debug printf statements, they are enclosed within this if def debug. So in order to enable debugging, so you have to compile your program using -d debug. That means define this macro debug. And when we compile it like this, and then what happens is all the debug statements will be printed. So all the debugging code that you have in your program, you can enclose them in these hash if def statements. That means what if def debug means is the macro debug defined. Okay, so the way we can define that macro debug at the command line by using GCC -D debug. Are you with me here? Does it make sense? There's an alternate way of defining debug. Like for example, we can even say hash define debug 1. That means we are debugging. Right now you are debugging the code. Like for example, when you are working on while you're debugging your program, you have line 4 enabled, and you compile the program and you run the program, and all the debugging happens. Once everything is done, you comment out this code and then compile your program, and those statements will be gone. You can even have a different levels of debugging. Like for example, if you want to see that we may as well do debug 0 instead of coming. No, even 0 is a definition, Gnan Prakash. I don't think it works. Okay. And also you can have different levels of debugging. So level, so One is no debugging, so none. So other is like, for example, you can have debug level 1. Any level after that, any number after that, it means we are defining the debug macro. So level 2, level 1 means, think of it as level 1 means a deeper level of debugging. Level 2 means, it's a shallower level of debugging. That is our mental notion. Deeper level. As the number increases, it becomes more shallower debugging. Think of it that way. Okay. So now what we do is, let's say we define no one, no, it's not defined at all, or 1 or 2. So what we can do is, for example, if debug is you want to print, so whenever you can say hash debug greater than or equal to 1. Okay, that is at level 1 debugging. So level 1 means deeper level of debugging. You want all the debug statements to be printed wherever they are. Okay, this is all hash debug greater than. It's not if def, so we need to have. Can someone check how do I compare a macro variable value? Is it just if debug greater than 1? Does it work? Or let's see if this works. If debug is greater than or equal to 1. What if, okay, oh, okay, it is 2 means it is the debug level, no, 2 is greater than, okay, we did greater than or equal to. So if the debug level is equal to 0, then that means no debugging, then nothing happens. Okay, got it. So you're all good now. So you understood when the debug, when we define GCC minus debug is equal to 0, nothing got printed. And let's say if it is equal to 1, then all the debug statements here, they got printed. Let's say we want to do one thing. Whenever we want to do an insert node, we want to do one thing, printf, we want to call the print list function. That is, we want to see how the hash if debug is greater than or equal to 2, then what we want to do is we want to see how it is looking like, how the list is changing. Before when we at the beginning of the insert node, and yeah, it is a bit painful to so just leave it like this. Okay, so we want to print whenever we want to call an insert node, we want to check the state of that insert node function. Okay, let's do one thing. Let's say we are debugging the code here. This is the place where we are doing insert, right? So what we do is this. So when we are trying to do level 2 debugging, okay. So now let's see what happens. Control. The story remains the same, but if it is 2, so if it is 2, what happens every time before we insert a node and after we insert a node, we are printing the list. This is what is happening. This is what is happening. So we can in fact say print list, printf state of the list before %d got inserted /n key state of the list after %d got inserted. See state of, now you can see /n is there, no? It is there. So you can see we have a very deep state of the list before 10 got inserted and state of the list after 10 got inserted. So when this is the first. Now state of the list before 20 got inserted and state of the list after 20 got inserted. And we are looking at inductive case +1 because 20 gets inserted at the end. Are you with me on this one? Why we get the state of the list? This is the state of the list. From here to here, this is the state of the list before 20 got inserted. And why are we at the inductive case +1? Because in the linked list, 20 gets added at the end. When we add something at the end of the linked list, it is inductive case +1. So because of that, we are getting this message and the state of the list after this is this. Are you all with me here? Does it make sense? And similarly here, now if you come down and if you observe, this is the state of the list before 20 got inserted, 30 got inserted, and state of the list before 30 got inserted. And again, this is base case, the inductive case +1 because 30 is being inserted at the end. So we are getting a dumping lot of information in order to understand how your program is progressing. But after everything is done, you know, you no longer want to worry about your program is debugged. You don't want to print all these. You don't want to print any of those things. So you just you just don't define that macro and that's it. So you get the normal program. Are you all with me on this one? Yes, no? Make sense? So these tools and tricks usually you learn, you know, in your 3rd year, 4th year, or when you go to industry. Very long time. After a very long time you learn, but if you learn it within your first semester, then it will help you across throughout. You will become much more powerful. The second thing that we would like to see, one more important thing that we want to see is the use of what are called as assert statements. Okay, so like for example, you can have an assert statement here. When a node is allocated, what is the invariant that you expect from that node? What is the invariant? Do you recall the code? What is the precondition when you are doing an insert node and when you do an allocate node? What is the precondition for this program to go through successfully? What is the precondition for this program to go through successfully? What's the precondition? The precondition is, you know, this allocate node, when you do an allocation, the next is initialized to null. The next field is initialized to null. If this field is not initialized to null, then the insert code, the way you have written the insert code doesn't work. Yes or no? So we say assert, we want to assert the precondition for this code to work is this, that this should be true. So now let's compile this program. Hash include assert.h. Okay. Hash include assert.h. So it's all working good. So, but someone, accidentally in the allocate node, he looks at the allocate node function. He thinks, hey, why are we unnecessarily, initializing node next to null? So he removes this statement. He comments on this statement. So what happens is you compile this code, and when you run it, it is still working. What is allocate node? It's not given, right? So how is it still working? No, its default value is not null. No, not at all. I have a doubt. Let me check. Okay. So then that means interesting. Locate node. Let's say in order to just make it interesting, let's say if I manually make allocate node next is equal to something like this. Okay, now it is filled. So for some interesting reason, it looks like a node next is initialized to null. It should not, it need not be the case, but it is happening. I don't know the reason. Okay, it's a very interesting that is happening. So, but in any case, let's say, so in this particular case, it is working out here. It should not be the case. I don't know the reason. Okay. because the language doesn't say that the node next is initialized to null by default. It's not at all the case. Okay. So in any case, let's say if this assertion turns out to be false, then what happens is, on line number, the program comes out, and then the program comes out, aborts, and then it prints an assertion error saying, no, this assertion, there is an assertion failure. Are you with me on this one, the assert? So it is useful for you to populate your program with these assertion statements. An assertion is a precondition. An assertion is a precondition. Usually when it's not a precondition. When you have a function and if you assume something for that function to execute, then that you encode that assumption that you have for the successful execution of the program as an assertion. Can you give me such a nice example of a precondition in any of the programs that you have written? Can you think of a precondition in a function? We can do that, but assert is a more elegant way of doing it. Whatever if condition. When dividing by something, that variable cannot be equal to 0, of course, that is there. Okay, perhaps you may out of bounds array. Yeah, that's a good point, Dan Prakash. So let's say we have another code. Let's say sort. Is there a sort program that we have? String sort.c. Okay, string sort.c, and yeah, so we keep this is a program. The size of the array is 50, max name len, and we keep reading here. And so here we can have an assertion, string without null at the end, out of bounds. Yeah, so you can use an assertion to check whether the precondition is satisfied. So usually what happens is, when you write a chunk of code, so you can have a precondition for that code to successfully execute. You assume for the logic of this code to successfully go through, some precondition is satisfied, and after the code is done, you assume some post condition needs to be satisfied. So what happens is, in order for you to be able to check formally whether this precondition and post conditions are satisfied, you can use assert statements to do that. Can use assert statements to encode the condition, like whether there is an out of bounds array or whatever it may be. Using the asserts will help you. Are you with me here? Approximately. So using debug statements and assert statements are very important. It will make your thought process very clear. It will make your debugging strategy very clear. Like for example, an example of this is, you can have before, when you have print statement, a precondition for this print statement is assert the number of names is less than or equal to max array size. Max array size 50. So if this is the case, if this condition is not true, less than or equal to, then that means you will catch it during the debugging process itself. You will end up with the number of names that you enter is large. Then what happens is when you print names automatically on line number 43 itself, you will catch it. Or even when you are reading names, like here you say assert number of names is less than or equal to max array size. If this doesn't work, then you will have, if the number of names is not less than, if it's greater than the max array size, then you get into trouble and you raise an assertion. Okay, let's compile this program and see what happens. GCC string sort.c. I have to use assert.h. Less than okay. So now let's say I reduce the number of names to 5. See, now read assertion, this assertion has failed and we get a code number. It shows the line on which the assertion has failed. You're all with me here? See, now what happened is I disabled the assertion when this macro ndebug is defined, then assertion is automatically, it will be disabled. Assertion is automatically disabled. So now what happens is there is a problem. Okay, there is a problem and the program crashed later. The program crashed later. Earlier, when we assertions are enabled, then we caught this error early on. Okay, we caught this error early on, and we exactly found out here this is the place where the assertion has been violated. No, it all got printed for a reason. So read names bubble. So the allocation still. So technically, what happens is if you use more memory than it is allocated, it can still go on until things go very bad for you and your program crashes. And because of that, the names got still printed here. Okay, because the stack is not used for any other purpose, and because of that, you got lucky and things work, and at some point you run out of luck and the program crashes. So what happens is, while the problem is somewhere, you get the problem surfaces as something else at a different point in the program, and you will take a lot of time to debug. You can see in this example, especially where you things kind of although there is a bug in read names function itself, because we are reading more names than the memory that is allocated, but still bubble sort went, print names also went, and then then there is the stack smash got detected, and then it got crashed. So problem is somewhere, but it is surfacing as something else in your program. But if you use your assertions during your debug, during your program development phase, then you will be able to catch them early on at an appropriate. Everything is done. You can perhaps disable your assertions by defining this, compiling your program with the GCC and debug option, -d and debug option. Okay. I see 91 students and now 82 students, 10 students gave up. Okay, no problem. They just came to check how I am doing. Good. Anyways, so are you all with me here? How you can use assert? We didn't take an example of post condition or loop invariant, or no, you should use assert very cleverly in order to see that your program is doing the right thing all the time. So now the last part is on, now we move on and look at what are called as memory leaks. Okay, so let's see. I am not yet sharing the screen. One more person left. Okay. More persons leaking out. No problem. Okay. Just give me 1 minute. I am getting something, setting up something for you. CD CP21A. All right. Now let's see what is happening. Okay. Good. So now let me share my screen. All right. So this is about memleaks. Memleak.c. This is the third idea I wanted to cover. So now take a look at this program. In this program on line number 5, we are allocating an array of 10 integers. We are allocating an array of 10 integers. Okay. So there are a couple of problems. Let's see. Before we, first of all, so first problem is on yeah, let's make it a much more simpler thing. So let me do one thing. So you allocate and then you say x is equal to null. So now what happens? Hey, your offline star is there? Semester 2? Yay, good. Congratulations, everyone. Awesome. Good, good. Are you listening to my lecture or checking emails? Huh? All of you got caught. Okay, I'm just pulling your leg. Okay, now tell me what is the problem on line 7? Congratulations, everyone. First of all, I am also excited to see all of you. And Congo. So what happens is you allocated, it's like this. You allocated a bunch of memory and but you lost the reference to it, so you cannot use it anymore. Yes or no? A bunch of memory got allocated. It's like, somebody put lot of money in a safe deposit for you and they gave you the key and you lost the key. What happens? Until you get the key, you will not be able to do anything with that money that is deposited in your locker. It got leaked. The money got leaked. It's not, it's there somewhere. No one can use it, including you, because you lost the key. No one can use it. There is something called as cryptocurrency. Some you might have heard about it. Things like that, people would have lost millions of dollars like that. So they have some cryptocurrency, they'll lose some key or something like that. And all of their millions of dollars just is gone. No one will be able to use it because in order to use it, they need a key. I heard even millions and billions of dollars are lost in crypto as they lost a key or something like this. Okay, so this is a bad thing. Okay, this is a bad thing. So do you recall our discussion on names? And let's say if you have a structure with field char star name, and then int some something else, some int age. This is a structure. And when we do an malloc, we do two-level malloc. One level malloc is we allocate an malloc for this whole structure, and the second level malloc is for this name. Yes or no? Do you recall this discussion? One malloc for the whole structure and another malloc just for the name. So in the memory, it looks like this. So this chunk of memory, this is name and this is age. This is the structure. And then there is one more chunk of memory where the actual name is present. And there is a pointer to this. But when we do the free, if you just free this one without freeing the associated memory for name, then that means you are losing out this key. We are losing out this key. Then that means this memory goes for a leak. Does it make sense? We talked about it. So we should free this memory also and then free this structure. So in order to capture these memory leaks are important when we are working on software which doesn't stop. Most of the production software, it's not like, it doesn't run and stop. The programs that you are running, what happens? They run, they do something, and then they stop. But the production code, they don't stop. It will be running all the time. And these memory leaks keeps on accumulating. You can have a 64 GB RAM or 128 GB RAM, it doesn't matter. Within a period of time, if there are memory leaks in your program, you keep on losing out memory, and your whole system memory gets hogged and you will crash your program crashes. So in C, we have to do the memory management by ourselves, but in Java, there is what is called as a garbage collection routine. So what happens is the leak that is happening here, a garbage collection routine will be able to recall it after some time. But of course, there are a bunch of challenges in the garbage collection routine because it's an expensive process. Because it's an expensive process. Expensive means, yeah. Okay. Are you all with me on this one? So what is the memory leak? Yeah, the garbage, all the garbage that is there, that is unclaimed memory, leaked memory, in order to claim it, there are expensive garbage collection algorithms, so which are done in programming languages such as Java, but not in C. In programming languages such as Java, there is a garbage collection routine that periodically kicks in order to pull in all the leaked memory, but it doesn't happen in C. So in order to understand what is happening here, so let's see, you compile this code. This is GCC memleak.c or GCC -g memleak.c, and then we have to use a tool called as Valgrind. Okay, so you can see when we give to Valgrind this a.out, it says, you know, leak summary definitely lost 40 bytes in one block. Okay, 40 bytes in one block. Does it make sense why we are losing 40 bytes? Because 10 into 4, size of integer is 4. So those 40 bytes is lost, and that's what it is saying. Total heap usage, one block, so in use at exit, 40 bytes in one block is still at use when the program is, that is when we allocated one block of memory, 10 into 4, 40 bytes of memory, that is one block. Okay. Are you all with me on this example? Can you do a memleak on any of your programs and see what is happening there? Like for example, let's say string sort. It is control O, string sort 2.c. Yeah, so here also, yeah, so here we are not freeing any of those things. Okay, so you don't need to worry. But I hope you understood this one. And similarly, I will show you one more example just now, which I got. Let's look at this code, this interesting code. Memleak 2.c, Control Shift I. Now here, what is happening? Is there any memory leak in this program? Is there any memory leak? Is the memory that is allocated on line number 8, is it leaked or not? The memory that is allocated on line number 11, it is not leaked because we are explicitly freeing it. So let's compile this program and see what happens. GCC -g memleak 2.c. Include std .h. See, definitely lost 35 bytes. So where is 35 bytes lost? 19 bytes are lost here and 16 bytes are lost here. Okay. So it says rerun with -- leak check is equal to full. Now it says, heap in use, heap summary, 16 bytes in one block are definitely lost at whatever blah, it gives line number 16. Line number 16, it is losing 16 bytes. And then it says on this line, on line number 9, 19 bytes are. These are not permanently lost, means they are lost when the program is running. You cannot use them. Are you with me on these two statements? 16 bytes lost on line 16 because the memory that is, because we are doing an malloc of 16, P. We are not freeing it before the program is exiting. So because of that, no, it says it is lost. And similarly, 19 bytes lost on line number 9. So you can use this Valgrind tool. It is a very, very powerful tool. And if you should use Valgrind, you can do Valgrind to do a whole lot of interesting things. Okay. I would like you to kind of take a look, study a bit more about Valgrind and see how you can use it. Before I conclude, I want to tell you one thing. In all these cases, when we are doing the printf, these error messages, we are printing them to standard output, but you should usually print it to what is called as a standard error. When you print it to a standard error, I want you to, this is the question that I have for you. I'll stop this lecture with this question. So what is the difference between line 51 and line 62? Line 51 and line 62. Line 51 and line 62. I want you to, should we use line 51 or should we use line 62? That's the question for you. I want you to think about it, and and if you have questions on that, you should ask me later. Are you all with me here? Line 51 and line 62. Do you see the change? No, check it and see. Check it. Dhruvan, check it and see. 51 and 62. Why 51 is better? Think about it. I'm not going to tell you the answer. So with this, I will